Alright guys, welcome to Planes Over It. I hope you guys are doing good. And before we actually continue, I would like to thank all my subscribers and all my followers on the YouTube channel. We have crossed 900 subscribers and 300 plus likes on Facebook. Thanks for the love and support, guys. Alright, so let's continue, and we will be doing 320 air conditioning today. And the disclaimer remains the same, since I do not want anybody to use this information practically, hence a short disclaimer. Alright, so air conditioning system. Now this is a very crucial important system in the Airbus A320, and the important components of the air conditioning system are the ACSC. The ACSC is also called as a zone controller. So if you guys are dealing with zone controllers, is the same thing, and it stands for air conditioning system controller. The older aircraft had the term zone controller. Now I think they've changed it to ACSC. Two air conditioning packs, trim air system, cabin recirculation fans, mixer unit. So we will be dealing with all of these. Now packs are the workhorses of the air conditioning system basically, and there are two of them under the belly. And if you remember, they are not pressurized areas, just for your reference. So these packs are fully automatic and independent of each other. Okay, so they do not need each other's help to run. They are completely independent. Now packs need sources of air to run because they are dealing with air conditioning system, and this comes through the pneumatic system, which will be dealt again in a separate video. So the sources of air are engine bleed, APU bleed, ground source of compressed air. So in case if your engines are not running, if you do not have an APU running, there these days to save fuel, there's a ground source directly connected to the aircraft, and that can be used for air conditioning of the aircraft. Alright, so this is the sources of air. Now this is what a pack looks like internally, and we will go through the whole circuit, how the air actually flows through the pack. So now air is entering the pack through the pack flow control valve on the top left here, this one. Okay, so this valve is pneumatically controlled and electrically operated. So what that means is, only if there is some bleed, if there is some air pressure on this side like this, only then it will open, irrespective of the position. This electrically operated means if the pilot is going to electrically switch it off or switch it on. Alright, so if even if it is on and there is no bleed here, this will remain off. Okay, so that's the speciality of the pack flow control valve. It will work in pneumatically controlled. It will work only when if you have a bleed. Alright, so next the air is sent to the primary heat exchange here. It goes all the way like this, where it is sent for initial cooling of the air happens. Okay, after this what happens is the air enters the compressor here. This one is the compressor, as you can see, compressor, this one, where it is compressed to a higher pressure and temperature. This is where a part of the pressurization happens. All right, then what happens is it goes upwards to the main heat exchange, where quite a bit of cooling takes place. Now the interesting thing about this is, after this compressor takes place here, compressing of air takes place, if the outlet temperature is greater than 230 degrees, as you can see, this is the pack flow compressor outlet temperature here, and on the ECAM, if this number turns greater than 230, alright, the 230 degrees centigrade, that is, it turns amber. Alright, so this is important to monitor if in case you're approaching that temperature. Okay, so that's on the ECAM. So next what happens is, now after the primary main heat exchange, the air is sent downwards to the turbine, this one. This is the turbine here. So in this what happens is the air is cooled again because it is expanding in the turbine. It expands and this cools it further. Alright. So at the end of this, whatever air we get out, okay, whatever air we get out here, oops, yeah. So whatever air we get out here is your pack outlet temperature. Okay. So that is also having a limitation, and that is 90 degrees centigrade, as you can see here. So the temperature is measured here. You can see this T here, and this is your pack outlet temperature. And this temperature here on the ECAM panel, because if you've seen the previous video, you know where the ECAM panel is. Alright, so on the bleed page on the ECAM panel, if it turns more than 90 degrees, it turns amber, saying that you're too hot for the temperature to be used. Okay, so I hope the pack is clear. That's how the basic functionality of the pack really works. And this is the hot air pressure regulator regulating valve. We will discuss about that in the coming slides. And now there are two ACSCs, the one and two. So one controls the left pack, the two controls the right pack. All right, so something more about the packs. So now there's a knob called pack flow on the air conditioning overhead panel. All right, so this knob has three options: low, norm, high. So now the pack flow has three selection options, and they are low 80%, normal 100%, high 120%. So it will give you 100% in normal position, will give you 100% of the pack flow. So what is happening is low is selected when there are less than 115 passengers. So this is important. Why would you need to, you do not need a lot of air conditioning. So if your passengers are less, you can probably choose a lower pack flow. Normal is more during normal conditions when your load is as required. Now, there's important thing is about the high. High is selected when the conditions are hot and humid. Very important. All right, and generally asked as well everywhere. Now, high gets, this is another important point here. This one, high gets selected automatically, irrespective of the knob position, whatever, whether it is low, normal, or high. High will get selected automatically, irrespective of the position of the knob, when either pack has failed, or APU bleed is being used. Very important. All right, so if you're using APU bleed and or your one of the pack has failed, the pack flow will automatically go to high. Okay. Okay, all right. Now, if the packs are providing insufficient cooling, okay, the ACSC will detect this, and then it will send a signal to the EIU, that's the engine interface unit. So what that will do is, suppose your engines are, they will increase the RPM of the idle RPM of the engine to get more bleed out of it, because since it's not providing sufficient cooling, it demands for more bleed. This also is actually valid with the APU. So APU has a similar concept unit, that is ECB, Echo Charlie Bravo, that is electronic control box. So ACSC will also send the signal to the ECB to increase the bleed of the APU. All right, cool. So we're done with packs as well. Now we'll discuss something about the overhead panel. So the overhead panel, how do we, the two packs basically serve the three zones in the aircraft. As you can see here is the cockpit, forward cabin, aft cabin. Okay, so these are the three zones that the pilot can choose. Now the pilot has the options to set these zones separately, independently, and they have an range from 18 degrees here to 30 degrees here, and 24 is the normal mid-range. So there's 18, there's 20, 22, 24, and there's 26, 28, and 30. So the pilot can select any of these temperatures. All right, now the most important point about packs is this last point that I've written here. Both the packs deliver the lowest selected temperature on the three knobs. So for example, if you have selected 18 here, and if you have selected 22 here, and if you have selected say 26 here, okay, the packs will function to deliver 18. All right, so very important point. Kindly keep in mind what temperature the packs will generate. They will generate the lowest selected temperature on the three knobs. All right, so this is very important and critical. Okay, and this hot air we will discuss in the coming slide. And these are the pack flow control valve switches. This one here, you can just switch off the pack basically. This is engine bleed, and the ram air is the switch that is guarded on the overhead panel. We will talk about ram air ahead. And APU bleed and this cross bleed will be dealt in pneumatics chapter, so you can just ignore it for now. All right, so we're done with this. Now here we come on the schematic of the air conditioning system. So the hot air pressure regulating valve, that is here upstream of the packs, is the one that is regulating the pressure of the hot air that is upstream of the packs. Okay, now what happens is, since you remember, the packs are going to generate the lowest selected temperature on the panel, that is here. If you select whatever temperatures you select here, it will generate the lowest. But suppose this guy on the aft cabin requires say 22, and this is taking 18. So there's a system of the trim air valves which add hot air as required. Okay, so the trim air valve adjusts the temperature of each zone by adding hot air as required. Since the green line here is the hot air and the pressure is regulated by this valve, and that adds hot air as required. So these valves are controlled by the ACSC. As you can see this line here, it is controlled by the ACSC. Both ACSC will control the trim air valves, and that will add hot air accordingly to give you the required output. Okay. Now there is this mixer unit in between here, as you can see, and they are working with with help of cabin air fans, recirculating fans, that is. And basically that is to mix cold fresh air from the packs, and also from the cabin air, to recirculate that air so that you don't have stale air inside the cockpit, cabin, forward or aft, whichever. So that's the job of the mixer unit, and then it continues to supply. Now, RAM air is the one which I was talking about here. RAM air, it's a guarded switch and used only during emergencies. All right. So for example, in case of a dual pack failure, if both your packs have failed, you have to descend to below 10,000 feet, and then RAM air supplies emergency supply of cabin ventilation. So RAM air is a flap that opens up, and you have outside atmosphere helping you to ventilate the cabin. Another place where RAM air can be used is for your smoke, removing smoke. Smoke removal procedure is there where RAM air is used as well. So it is a guarded switch on this air conditioning panel. So you have to actually lift a flap. There's some small flap here, and then only you can turn it on. RAM air also, this flap will work only, if you have meet certain requirements. So for example, one is your 10,000 feet requirement, and the other is your delta psi, the differential pressure between the outside and the inside air should be less than or equal to 1 psi. So only then your RAM air will function. All right, I guess that's all about air conditioning. I hope you guys have enjoyed the video. And thanks for watching, guys. Subscribe to the YouTube channel and like the Facebook page for regular updates. Give the video a thumbs up if you like the video. Do not forget to share it too. Comment below if you have any doubts, of course. I will surely get back to you anytime. And cheers and happy landings, guys. That's all for now. We will be dealing with, I think, avionics ventilation perhaps in the next video. And till then, guys, see you. Have a great day. Thank you.